Okay, so hi everyone. This is a third attempt to record a meeting, a, a, a demo of a small POC project that I've worked on. A POC of a project called Kubernetes Management Cluster with an NDAP. And really, this is just to demonstrate. This project was really meant to demonstrate a certain pattern, a design pattern that is used in services. When you want to design a complicated service that manages a lot of things, this pattern can be really applied and used, and it'll actually outsource a lot of work to already existing frameworks and tools and systems. And so I want to really kind of break the talk into three parts. One is I will essentially talk a little bit about the pattern itself. Where does this come from? In general, how does this work? Where that can be applied, and so on. And I'll actually look at the particular example from the beginning. I'm not going to talk a little bit. I'm not going to talk in general terms what this is all about. You can actually see that by yourself. The second part is going to be about particular application of this pattern in and with an NDAP platform, how that can be used, and how I used it with an NDAP platform. And then, and the third part, which is going to be recorded separately, is going to be an actual demo of this project and what it does and how it works. Okay, so let's go. So first part is, what is this pattern? Where does this come from? What problem does it solve? All right. So I'll jump into example right away. So this pattern, as far as I know, has been designed by a different company, but now I know for sure it's been used by many companies, and specifically I know the application in VMware, specifically with their VMware Tanzu solution. And VMware uses this pattern to actually help them manage their fleet of their data center fleets. Okay, so essentially what this pattern represents is the following. So there's the problem. So for VMware has its own data centers, and there are multiple of these data centers. You can imagine this is one data center, right? This is a big one, and there can be another data center next to it sitting, right? And each of the data centers has like a middleware. This is middleware. This is also middleware, and in the data center, you can imagine there will be, you want to create multiple virtual machines, right? VMs, and maybe there will be some disk storages, and multiple of them. So these are maybe connected somehow, and there are more VMs in this data center, and there are more storages in here, and there can be many more resources you can think of, and maybe these things are interconnected somehow, and these things are interconnected, and so on. And essentially, this is nothing new. You have your data center software or soft data center which is like a virtualized or a hardware data center. And of course, the idea here is that we want to be able to manage this all in one place, right? So the normal way of doing it, and all the communication can go with middleware. So each middleware can have its own, you could say like maybe UI or something like that, that let manage its own local resources, so localized to the data center. But the problem is really, the problem really comes from the part where, essentially you want to really talk to these two parts, two middleware parts, kind of like in one place, and make it all controlled by the API calls, right? So you want to do this all programmatically in a controlled fashion, the usual thing, right? So what you can end up doing is, for example, let's consider our option, right? So that's our data center. Now what we can have is that we can write our own cluster. We can write our own service that sits here, and it pretty much talks to, like through the API to this middlewares, and it basically, the service would have its own UI page, possibly UI, and whatever else it may have. So there may be a database as well to keep track of all of that, and it's going to be a fairly complicated service, to be honest. But what it really does is it just really sends the messages to this to the middleware parts, and really talks to the data centers through the middleware, right? And what VMware actually did, they've decided that instead of creating all of this complexity over here, all of that, instead of doing all of this, what they want to have is they want to really just have it all outsourced. And what they've done really is that they've basically, their approach to this was the following. They create a small Kubernetes cluster. We call it Kubernetes cluster, right? And like any other Kubernetes cluster, it has its own kind of underlying parts in the cluster, right? So what we're interested in is an actual ability of the Kubernetes cluster, or Kubernetes generally, to be able to be extended with custom API, custom resources. So what VMware did, they defined custom resource. So let's look at the use case. The use case is fairly simple. Let's say we want to create a virtual machine, right? So the use case is fairly simple. You create a virtual machine through an API call. Like here, you basically start from here, and you make a call, and it just creates the virtual machine, and you sit and wait until it's created or something like that. So what VMware does is that they've decided that they have a custom resource, CRD called VMware VM, and this custom resource, really, it will be what it's gonna do is this is gonna work in the following way. So when you want to create a virtual machine, the user, all the user does is really, let me just make it a little smaller. So the user will talk to the Kubernetes cluster, and they will create this resource VM, which is essentially meeting the specification of this definition, the custom resource definition, right? And what happens next is that in the same cluster, there is a special compute resource, controller is running, right? And what happens is that when Kubernetes see this is happening, so this is a user really just sending a request, a normal request to the Kubernetes through the Kubernetes API to create a resource. So it's a post operation. And you're using a CLI tool, it will be like a regular apply, kubectl apply, and then you'll point to and you'll send a normal YAML definition of the resource. All right. So what happens here is that whenever this resource is created, first of all, the first step that happens is that Kubernetes is gonna really check if you're allowed to do this all operation. So it actually follows all the airbag definitions and validates if all the policies are met, and you just through the policies you can create this virtual machine, this resource really, and then this is important to create this resource. And then what happens next is that it will actually check if the resource meets the spec definition in the CRD itself. Once this all happens, it will actually notify the controller with the event that the resource has been created. And what happens next is that this resource, this controller, it will actually take this event and do something with it. So what controller normally does in this case, in the VMware case, it will go and it'll actually pick, for example, one data center, and it'll say, hey, create a virtual machine here, right? And of course, it'll get an answer over here. So one important aspect of this whole operation is that this resource normally consists of two parts. One is the upper part is a specification, right? So this is really the spec part, and that's meant to be done or edited by a user. And then there is a bottom part, which is normally called the status. Right, and the status is only readable by the user, so the user can actually look at the status, but they cannot change the status. But the controller works another way around. So the controller only can, or is supposed to really, only read the spec and write the status. So what happens next is the controller, once the request is sent to this middleware to create a virtual machine, the middleware will probably reply, yes, it's in progress. All right, this is your answer, it's in progress. So come back later. So the controller will go and actually it would write the status of the reply to this resource, right? So it'll say whatever, maybe an ID, a reference to this virtual machine, to the reference to this resource, which is a resource in this data center, in this data center, right? And then what happens is that the controller will really release the control. So it exits, so to speak, right, from its main function, and the result code will be that retry, because we don't know if the virtual machine has been created yet. So what it says to the Kubernetes, it actually kind of, after the reply comes back from here, it'll say to the kube, answer, retry, right? So it's a temporarily failure. And what happens next is that the Kubernetes will wait for some time, and there is a way how to define how long to wait. You know, there will be a back off procedure and so on, so not to overload the controller. And then it'll come back with another event, which is this very similar event compared to the first event. So this is the first one, create. So the second is also going to be create. Right, and it's the same retry event. So what we're going to do now is that we're going to go and check what's the status of this resource. And we see that the status is already creating, right? So we know already that this machine has been created, is in progress of creation. So what's going to happen is that we're going to go and read the status of this machine on the second request and get an answer. And if this machine is already done, so the reply comes in back, and we update the status once again, and maybe we'll say the machine is created or something else. You know, basically, we just completed our, and then we exit the function again, right? So this reconciliation loop. So the term is reconciliation loop. We exit from that, and so what happens is that we created this. So we've just created this custom resource, and we updated its status, and the user can go and actually just go and read the status, or just generally can go to the Kubernetes cluster and pull the list, the list of, for example, virtual machines, because as you guessed, there can be many of them. There can be 1, 2, or 3, and so on. And each time this resource is created, the controller will receive its own singular event. It's not going to happen concurrently, and even if it does, the controller shouldn't experience any problem, because these are completely separate resources. They don't have any conflict with each other. So the user can list these resources. It can delete it. Well, they can delete resources, they can create resources, and create, and so on. So you can imagine basically what else can be done with those resources. So in general, what this pattern does, of course, is that you can kind of represent with this resource, with a virtual machine resource inside of the custom resource inside of Kubernetes, you can represent a real resource outside of the cluster over here, right? So you could literally kind of connect them virtually, right? Now, kind of to draw, to go in a little further, you could say that there can be another resource called disk, yeah, so disk, and then you could have also its own status over here as well, and disk will have disk has its own controller sitting next to it over here, right? Another controller. And then what happens is that, for example, whenever you create a virtual machine, you can actually, in the specification over here, say, hey, there's a disk that I want to use. So what happens is that when you create the disk, again, the Kubernetes will send an event to the controller. Controller will, of course, talk to cluster, right? And it'll actually set a status to whatever. For example, provisioning, right? So not ready. And then, so let's go back to our virtual machine case, right? So what happens here with the virtual machine then, because it refers to this disk, so it says use disk number 1 or whatever the disk number or name is. So this controller will check, because it can actually read this resource as well. It cannot write in this resource, but it can read the status, right? So this is important. It can read the status. It will read the status of the disk. We'll see that the disk isn't ready yet, so the status isn't ready over here. And then it'll immediately exit the reconciliation loop, and it'll tell retry in 10 minutes or retry in 1 minute. And the Kubernetes will again send the creation event, and it will repeat this loop until everything's ready, everything checks out, and the controller, in the end, the controller's reconciliation loop should exit with a successful result. So as you can see through this pattern, what happens is that we've just created a meta resource for disk, right? We've created a meta resource for a virtual machine, and now we kind of created a dependency between these resources, so that when we create a virtual machine that refers to a disk which is not ready yet over here, right? So then the virtual machine will not really work, or will not even start its provisioning until the disk is ready. So then when the disk is ready, the controller will retry, and it'll read the state of the disk. And when the request is made to create this virtual machine, it'll just provide the ID of the disk or something like that it can read from the status of this custom resource. All right. So another interesting thing that you can say is that whenever you create this kind of like dependency or like links between two objects, right? You could kind of say who's the parent of whom. So you could say that kind of relationship as well in Kubernetes. And so then when one is deleted, for example, if you want to delete this resource, what happens is that Kubernetes will actually either notify this controller first, or it will try to delete this resource itself, right? Which will, of course, in its own way, trigger notification to the controller. So you kind of create these dependencies between the resources, so that when you don't have sufficient inputs in, or some dependent resources are not ready, you're not even starting your provisioning. So everything is consistent. And the second is that it can actually handle cascade deletes and all other things like that, very similar to this, right? So that's roughly in a nutshell the use case that they're trying to cover with this model. So let's stop here for a second and think, what did they do with this, right? Again, kind of looking back at this kind of design that they could have used instead themselves, this part. They've just let an external service that they don't even have to run. They can just rent it, or they can run it in the cloud again, so they don't have to really maintain it themselves. They let the service manage the life cycle of their resources, representing the resources in this cluster will represent a real state in the data center. So over here, right? So they will literally represent the state over here. you essentially outsource the entire protocol of managing your resources to Kubernetes, which has a very reliable, very extended model, very extensible model as well. So you could extend it with anything you like, right? Keep track of that resiliently. And more importantly, your components now, because the management of your components is done through the controllers over here. The controllers themselves they're stateless and they're very independent. So you essentially let the management of your platform to be handled completely separately. So it's a separation of concerns really from the perspective of the controller. Because controllers are stateless, they can easily stop, restart it and such. And Kubernetes really will essentially just keep the state of these resources in its own service state, right? And that is very reliable because Kubernetes is relying on like very, very reliable way of handling a consistent state of its own resources. So that's pretty much the case with Kubernetes, right? Okay, so let's see what we can do about it with an NDAP, right? So what else? What problem are we trying to solve here? All right, so let's see. All right. Now let's look at an NDAP. So what is an NDAP? An NDAP, this is the second part. The second part is how we can use this with an NDAP, or for that matter, with any other platform. So let's see what an NDAP offers, how it offers, and how we can approach that. So let's see. An NDAP normally is a platform which is deployed in your subscription in Azure. So it's an Azure-based solution, right? And this is your subscription, right? So, and I would say that you could see this as broken into maybe three parts, right? So kind of like for myself, mentally, I divide it into three parts. One is that, of course, when it's deployed to your, and abstractly, when it's deployed to your subscription, it will provision a bunch of resources, right? There are some resources in compute resources, I don't know, some other resources, network resources. So this is all different resources. But more importantly, this is just resources in the cloud, that it will create a pipeline. And for the sake of argument, I will draw several pipelines because whenever you run a pipeline with different parameters, I would consider this just a different pipeline. So that it'll create a number of pipelines here that you can run that perform different functions. And it also creates a repository with a bunch of files with YAMLs. There's one YAML, there is another YAML, and I'll explain what these files are, right? So this is really a repository, so to speak. So what happens is that when we create this configuration in your subscription, notice first thing to notice here is that it's already spread across many things, right? So this is essentially compute part. This is DevOps part, right? And this is source control part, which is also part of the DevOps, but it's kind of like you could see this a little bit separately later. Why this is the case, right? So these are YAMLs here, right? So what's going on here is that once this is all deployed, you're as a user supposed to do the following thing. You're supposed to run the pipelines one by one, and again, I'm reminding, for the sake of argument, I'm thinking of it as a separate pipelines, but in reality, this is the same pipeline with a number of parameters being switched around and so on. So the important thing to remember here is that you run them in a specific order, right? And what these pipelines do really, they would go into the compute part of the Azure, and they will deploy bigger parts of an NDAP platform. So like really, you could say like like really, well, kind of like resource groups or multiple resource groups containing multiple resources and so on, right? So we do this. And so the NetApp platform is designed in such a way that it has an abstraction thing called component, right? So a component is really a collection of resources, different resources that are deployed in a group in your Azure, and you could have multiple components deployed in your platform, and each of these components will have its own part, like its own collection of resources, of course. And you don't have to deploy all of them, but whenever you want a component to be applied in your platform, you just run a specific pipeline. So maybe you don't want to run this pipeline, but you skip it and you run the second pipeline, the third pipeline. So this is a component called whatever, data extraction, and then we have data quality, for example, right? So maybe you don't want this, so you'll skip it and you just jump right away to data quality, and that thing would essentially go and provision that part, right? And the first part is what we normally would refer as an installer. It's essentially deploying kind of like the essential part of the platform. So this may be the first step, has to be run always, because without it, this thing wouldn't even be able to talk, because maybe it uses some, I don't know, some network from here or a storage account from here, whatever else. So there is like this soft dependency realized in a pipeline, not the pipeline, in resources, right? So and then so these are components, and then there is another abstraction layer which exists, is that each of these YAMLs over here, each of these YAMLs technically represents something what we called also custom resources, very similar to Kubernetes. So I'm just going to draw them like here, like small boxes, to be honest. But you can think of them as maybe they are stored in these files. Like in one file there can be several resources. It's similar to Kubernetes. So what these do, so when you run the pipeline again, maybe the QLite pipeline again, this thing, or actually, better yet, not from here, but another pipeline will look at these resources, because now it's looking at the source code. And what it doesn't maybe provision the resources in the cloud, but what it does, it's going to go to this component resources, and it'll actually try mutating them, configuring them, so like basically changing certain properties. So mutating this component a little bit, so it's working in a desired way, right? So this custom resources over here, they kind of represent the configuration settings, if you like, and this step, which we call configure, would just go and tweak this part, or maybe it will tweak this part too, or maybe there's another pipeline that will do something else. Essentially, it's somewhat like arbitrary in a way that it can also provision resources. Maybe it'll actually create a resource and then mutate resource, and then can make connection between these resources. But you kind of like, you have to always mind that's like, it can do many things, right? And then the problem of this whole setup now is that, imagine you're a customer and you want to know what's the current state of your platform really right now. So first of all, in order to see what's your configuration, what's your applied configuration, you may want to go, kind of maybe over here and look at your source code. But that's not really good enough, because who knows if this thing didn't fail, or this thing didn't fail, or this thing didn't fail, or I don't know, maybe cloud failed altogether. That could happen too. So yeah, you have these resources in the source control, but what else? I mean, it's not really good enough. It's a desired state. It's not an actual state, right? The second thing is, now you have these pipelines over here. So now, if you want to know if your component, for example, data quality, has been provisioned, what you have to go figure out is that what's the last status, what's the last run of this DQ pipeline is, data quality DQ is, and was it successful? Because pipelines really don't have a status; they just only have a result, and it's last result. And you can imagine, by the way, these pipelines also run Terraform. So technically, Terraform is also a little tricky. It may not complete entirely, and so on. So there are a lot of kind of like nuances about how you run a Terraform from a pipeline. And remember what I told you, that the pipeline itself actually is one pipeline, and it's just the different parameters of the pipeline. So you could say that Terraform pipeline is responsible for creation and deletion, and depending on which parameter you provide to the pipeline, it will do one thing or another. And that creates a whole different array of problems, because now if you want to know was the project deleted or created, you have to find the pipeline that was run with the parameter delete, and then check its status and make sure that when it creates ran at the same time, right? So this is another problem, reading the state of this whole thing, right? So, and then the cloud as well, right? Like I said, you have kind of these big resources, or modules like this. So quite frankly, in the cloud, yes, you can go and check the status of the virtual machine, and yeah, it's running, and there is a network maybe, and it's also available. But what's the status of my component? Is that actually working together? Or if I provision this thing, and like, is it even talking to my other components? Is it live? What is it? What's the state of my component? Well, the compute part of Azure doesn't care what's your aggregated state or what is your complex state is. It can tell you, oh yeah, this machine is running, like this virtual machine is up and running. You could see the logs, and this network is, sending packets. You could see the counter, but nothing else really. So, again, the problem is question mark. So what's the state, right? And altogether, can you even just go and look at the compute part and say which component has been deployed? Can you go and look what configuration has been applied here? Because, it's a mutated state of the component over here and over here. So you have to kind of go and check, for example, this virtual machine, what are the files here, or maybe what are the files here, what are the disks here, and then maybe then say, oh yeah, so my config, this config was really applied, right? So I mean, it's difficult. It's not impossible, but the point here is that there is a lot to do, and it's spread across multiple APIs, right? And by APIs, I don't mean just Azure API. I actually mean like big, APIs, like going and looking at the files, going and looking at in the virtual machine, maybe pulling some Azure API, maybe going through SSH, and then there's a complex computation in the pipeline, which one ran fast or last, or is it succeeded? So yet another API with a lot of uncertainty, and it's hard to really work it out. So that's my personal perception of the problem. So what I've done is I've applied the cluster management pattern here, and so here it is. So what I've decided to do is, first of all, that's nice and beautiful, but we don't want that. We just do this. So what I've done is, and again, remember, this is kind of like a POC, so I wanted to just demonstrate the simplicity of certain things. So I've decided that I will have, I've kind of come up with 3 layers of resource abstractions, right? So I have 3 layers. This is layer 0, layer 1, and layer 2. So layer 0, or level 0, call it whatever you like, is my resource, custom resource called platform. And what it does when it is responsible for essentially go into the cloud. So when I have that resource, what indicates, and by the way, one other big thing that I didn't mention in the first place, that this all picture, so this whole everything inside of the subscription has to be also provisioned somehow, as a first step. So customers are supposed to run that, or whoever is supposed to run that. So to just set up this whole layout all together, create the pipelines, create a repository, place some basic files into the repository, and kind of like maybe deploy some essential part to the cloud itself, so something like without something that wouldn't run at all, set the policies in the subscription and such, create a print service principle, something like that. So my platform resource level 0, what it's going to be doing is that whenever I have this resource, it's going to represent the whole thing, like here. This is the whole thing, right? What I've just described. Then I'd have level 1 resources, which I would call components. That's exactly what we have, components. So I have data extraction component, and maybe some other components, whatever. And the third layer could be, something like an equivalent of these config files, something like that. But kind of like, I don't have them implemented, but you can imagine that could be like a level 2 as well. All right. So essentially, what's going to be happening right now is I will have my kube cluster deployed over here next to this whole platform. And I will create my platform. So again, this is my underlying of my kube cluster. So this is my platform custom resource. When I create it, well, I'll just skip the CRDs. So I have the controllers, CTL. When I create this, when I create this, and when the user creates this, so the user comes in, create the custom resource platform. So the controller receives this event, and it reads whatever the inputs are in the specification of this thing, and it goes and, of course, through the API, basically deploys the entire picture. To be honest, it doesn't have to do this. It can just go and check if it's all in place, but kind of like hypothetically, you could imagine this. Platform, by the way, the platform. But this is level 0. This is very important, level 0, right? So it goes and, maybe it checks if everything is set up correctly. So in my particular POC, I don't deploy it because this whole setup is immensely complicated, and I didn't want to waste time on doing it. So what I'm doing is that whenever I deploy this resource, all I do is I read some parameters from this specification, and I go and I check over here in the subscription, and I point to one particular subscription, and I go and check if these things are in place. So for example, I go and I go and I check if the project, even if the project exists, with the source, with the source control, and if the pipeline exists. These are two things that I'm actually checking, if the certain pipelines that are checking, right? And if it's there, I'm gonna go and I say, hey, this thing is ready. So I'm gonna say, okay, this is good. So the status is set okay. Now, the next level of abstraction, like I said, is component level. So again, I create my component. I call it data extraction. This is a real component in our NNDAP. And what it's going to do is that it's just, again, it has its own controller. So there's going to be a controller, and it'll talk to the controller. Well, controller will get the event, create, and it'll essentially go and, in my case, well, let me change the color a little bit so it's just a little bit different. So this is already level 2, right? So it'll go and it'll actually run the pipeline. That's what users are supposed to do when they want to deploy a controller. when they want to deploy a component. They're supposed to run a pipeline. But users don't see this. So whenever a user comes in to the Kubernetes and they just, when they deploy resources, they use the same API. It's one single API. They don't have to worry about, going and checking, if it's one thing or another. It's just one API. And I run the pipeline and I sit and wait, until the pipeline completes. And I would then say, it's deployed. Okay, it's up and running. And in addition, on top of that, what I can do as well is that I can occasionally, kind of ask the Kubernetes, hey, can you send me event in 10 minutes? So that I can go back and maybe, whatever, I can maybe run the pipeline again just to make sure it's all deployed and that, it didn't drift. Or maybe I can go and poke some resources and see if it's all up and running, and that's going to be a fairly complex model, how to figure out what's running, what's not. But again, what user is going to see, oh, it's then okay, or maybe it failed because of something, whatever, But again, you can see that. And of course, when I'm deploying the data extraction, what it does, it really, before it starts, it's going to go, well, data extraction will say, I want to deploy it to the platform, to this platform, right? So the controller will go and check, oh, what's the status of this platform? Is everything in order? Because you remember what it does, it actually goes and checks. It goes over here, and then checks if everything is deployed first. And that's how we get the status okay. So what I'm going to do, I'm not going to do this all the checks. Why would I bother? All I need is to go here, check my OK status. It's okay. Brilliant. Then I can deploy my component. And this component will actually, it may fail the deployment, but hypothetically, this is the job of the controllers to make sure that the status of each of the resource in the Kubernetes cluster represents their actual status of whatever your deployment in the cloud and such, right? So, and then you could think of maybe other third layer, second layer, call it anything that is really corresponds to, well, those smaller resources over here that I said they're really like other CRDs, but I didn't go that far. So ultimately, I only have right now these two resource level 0 and level 2. Level 0 and level 1. These two. I have only one component, so it's a data extraction component. And there is a light dependency sitting between them. So whenever I create a platform, it will actually go and check if something's deployed, if the cloud is ready, so to speak, like a very simple check, but it does it. And then it checks, it sets its own status to OK. And then data extraction component will not deploy until the platform status is okay. And if the platform status is okay, it actually fetches some status, some real data. It actually will fetch something from this resource, something from the status, something that the controller of this platform sets together with the status okay. It actually puts there some values. So it'll actually fetch these values and it'll use these values in its own deployment of data extraction. And of course, it's not going to really deploy things, it's not going to run Terraform or anything, but what it does, it actually would go and run, trigger the pipeline, and then it'll actually keep waiting until the pipeline's up and ready, right? So ultimately, the API of these controllers are all Azure DevOps pipeline client. So there is nothing else besides of that, just that. But even with that simple API, by the way, you could already see that you're representing, you're letting user really seeing the state of your cluster through this API, the Kube API. And what I really like the most here is that the users now they can really create these resources, this level 1 or level 2 or whatever, level 0, in whichever way they like. The beauty of Kubernetes, of course, is that there are so many tools that you could use to manage your resources in the cloud. There are some UI tools, there are some so there are some CLI tools, there are tools that sync it with Git or with anything else. So essentially, what I'm saying is that we can draw a very strict, like very thin line or thick line, well, basically a line between the platform and the user. And there is just one API that really is left to the user to interact with, which is the Kubernetes API, which is very stable, very reliable. It has a lot of good properties, like it lets you manage versions of resources very seamlessly. There is a life cycle, it's extendable. There are lots of tools available. It's popular, everything essentially. Everything is good about it. Well, so and then we could, as a best effort kind of thing, what we could do is that we could even help customers to maybe, create a repository somewhere, wherever that repo can be, Azure DevOps or somewhere else, and maybe sync it with their, cluster, so that, they get a very similar behavior to what we have on an NDUP when we store the resources in the source control as well. So this is going to be a very similar functionality, but there is it's only on the surface different. The major difference is, of course, that unlike with the model that we have, this is there's just Azure source control. This is optional, and it's very transparent. You can use any tool you like. It doesn't have to be anything, and it's just really, I would say, it's not a problem of a platform engineer to really handle that part. It's more like a CI/CD kind of problem, where you're synchronizing stuff from your repository. In addition to all that, of course, like I said, there's one other interesting aspect of that, is that when you're having this model, what you could have is, you could imagine there can be, let's say another subscription over here, and there can be another platform over here, and this is going to be here. So you could have multiple platforms, multiple resources. This resource will relate to this platform, right? So something like that. So you could have multiple platform, multiple components, multiple everything managed in this one singular cluster. And because it has all the RBAC policies configured, if you like, it can really be your kind of central point of management, the resources. Not necessarily an NDUP resources, but any platform or any deployment resources. If you're able to come up with some abstraction meta resource that can be represented in Kubernetes, that can be represented in Kubernetes cluster, it can be managed, which life cycles is similar or can be aligned with the Kubernetes lifecycle, Kubernetes resource lifecycle. This model can be applied there too. And, effectively, I guess this is it about the second part. So you could do that, with any kind of platform. And as a closing note, I must say that, of course, this example will be with Kubernetes, right? So this is a Kubernetes cluster, and there was a Kubernetes cluster too. But you could actually use any cloud, because any cloud provider these days allow you to extend their API with custom resources. So the Kubernetes in this example is just my approach to this, because I know how it works in Kubernetes, and it's fairly simple. And I looked at how it can be done in Azure, for example. It's a little bit more complicated, but you could still have that same behavior. You could still have the same resources, and they will be handled with the same controllers. Well, controllers would have to be written a little bit differently, but the life cycle of the custom resource is fairly similar. You could do this with AWS, you could do this with Azure, you could do this with Kubernetes. So this can be any platform, any cloud provider you like, and it could really just abstract away a big part of the configuration management of your resource, of your platform, help to clean up your interface to your platform, really, for the customer primarily. And you wouldn't outsource a lot of tooling and whatnot, processes, to the cloud provider. So that's it about the application of an NDAP with a pattern. So, and then I'll record another demo of that in a moment. That'll be primarily just a demonstration of how it works in Kubernetes.